here in the program. Going to go to my cool function in my programming here. I'm going to add one line of code, and basically it always loops through. So there's little things I put in there that happen if a certain condition is true. In this case, it's going to be if my pulse width modulation, the duty cycle, is still at frequency minimum when it gets to this point, and the outside air temperature is greater than 80, it's just going to jump the pulse width modulation, the duty cycle, up to my starting frequency I've programmed in, which is basically the fan stopped. Phone call interrupted me. Where was I? So that's going to jump it up to 110. And then the next time it comes through, this will be meaningless because the pulse width modulation won't be at minimum. It never will be when it's over 80 and it's running, except for the first time it starts. So that's just to kind of kick it up. After that, it'll normally just add or subtract the duty cycle as the temperature thresholds, change right there. So the only issue was it was just going and having to slowly increase the duty cycle as the liquid line temperature responded, but the fan slowly changes speed, as it goes through there. Now, if I would have made it jump more values every time I went through this repeats, it would be faster, but I don't want to do that. I want the fan to slowly respond once it's running. It's just that it needed a little kickstart when it's warm out. So I just added one line of code, and that should do it. So I'm going to go take the programmer. I got it programmed and programmer to go, which means it's put in memory in here. I'm just going to bring the portable battery. I'm going to go hook it up out on my heat pump controller and dump it in there, see what happens. Something else I need to change is the hard coding of the default for my fan speed. So when I first write to the chip, I got a value of 65, which hexadecimal 41. I don't know why I tortured myself with that. So go over here to decimal. Let's say I change that to 70. That'd be hexadecimal 46. I guess adding 5. Pretty obvious there. Right around 200 is max speed, so I'm just going to go ahead and start this as low as I'm just going to add 60 also to the value just to get the fans going, and if it starts dropping too much, you can always just back itself down. This is just how it gets going on first start. So I'm going to do that, and also write it to the PitKit 3.5 or whatever. And it should be ready in programmer to go mode. Once it gets done with that, just kind of got the little scrolling thing over there. PitKit 3 is now in programmer to go mode. The next time you connect it to this unit, you have the choice to take it out of that. Yep. So when I power it up, it'll be ready to dump what's flashed into this into my microprocessor out there. The reason for all this racket right here is just that I'm testing out some different MOSFETs for running a radiator fan. So I could change the speeds on there. Oops. So just kind of seeing how hot they get. I can hold on to them, so it's 130 probably. Small one is not as hot as that big one that came out of the Frederick, but that's because this is made for lower voltage, decent current, and this one's made for high voltage, but from the Frederick unit. It's a 600 volt rated MOSFET. You usually don't use that for switching 12 volt devices, but if you can get away with it, go ahead and use it. And I already have those MOSFETs, so that's why I'm testing it. Okay. Power supply turned on. PitKit is lit up. You can kind of see what's going on there. We're going to push the button, and the LCD is just showing the last commands it got, and it stopped because microprocessor is being written to, and there it goes. Do a couple of refreshes. So now I should be able to unplug this, unplug it. When I plug it in, should have today's date that I wrote in there, April 17th, 2024. And the liquid line's still hot, so it's already going to start turning the fan on. So unplug that. The high voltage on. Now I still have to fix some shielding issues. Every once in a while when this thing switches the reversing valve, it induces some noise on here. But once it's running, it's been fine. This thing's ran like over a month. So see, it does that sometimes. There it goes. It'll be fine now forever. Alright, so cooling low, fans are already starting to rock as soon as it started. It's because it instantly started at fan speed at my default plus the amount I put in there. So 130 instead of starting from 70 or whatever it was and slowly going up the duty cycle. 70 is the fan motor stopped. I'm just creating a DC voltage output. Think of a 2 to 10 control, but it's like a 1 to 6 volt control for these IPM boards for these fan motors. So got pulse width modulation happening right over here, the interface to that board. So I was just starting down at basically the amount of voltage out that's the fans are stopped, and then it was, as the liquid line warmed up, it would start increasing the duty cycle. But when it first started, being that the fans are starting from dead stop, it just takes a while for them to rock and get going, and it's just a little the head pressure would kind of go up kind of high and then drop back down. It never tripped, I just didn't like it doing that. So now obviously the liquid line, this is the Horma stays, it's like 93 out, so it's the liquid line is only like 102 now, 104. The fan motor's already getting to 170. I might have to increase the max speed. Oh, and it might already be at it, it looks like. So I got to go in my buttons and increase that. I forgot to my hard coding, what's in my program, right, is I got the fan max duty cycle at 170. 255 on an 8-bit value is the full output. So I think I jacked that up to like 190. I probably need to put like for 200 or something. So I need to get in there and change that. I'm not going to do that on camera because it's tedious and I don't want to screw anything up, but I'm going to do that real quick. Okay, I'm in there now. So see 170, and I just hit the stop button on the VFD to stop the compressor. Fans are still kind of going because the line's warm, so I'm going to set that for 200. Now the software, when you first dump it in there, that hard coding is just like it's putting the initial values into the EEPROM that's built in here. So I do have memory that, you know, it doesn't lose when the power goes off, you know. So now that I'm setting this, it rewrites it. See, I programmed this to do this, so we're gonna put save the EEPROM. So now when it first powers up, see how it's increasing, trying to cool off the liquid line. I need to go to auto, which I forgot how to put it back. Oh, I think with these won't go back to auto. When you that's what's going on. Still in low. Then shut thermostat, I'll kick it back up to high since we're not running there. Fans are already starting to go. It's already at fan speed 1. That's actually dropping because the liquid line cooled a little bit. So it's actually dropping from my starting point. That's kind of balancing out. It should start going back up. And it's not running yet. So I don't like that it actually stopped. So I got to tweak with this a little bit. I just thought of a better thing to do. Instead of just giving it the bump start that way, I think I'm just going to lock out it being stopped when it's over 85 degrees outside, and just basically every time it comes through there, the F minimum is always going to be the what it loads from EEPROM, you know, plus, you know, a certain amount of duty cycles. So I'm going to add 40. I think that'll keep it from, it'll make it really slow, but not ever be allowed to stop or be stopped when it's over 85. So it should just jump right to that. So I'm going to write that to the programmer, and we'll go try that out. This is where you really get to play around with conditions to make things do what you want them to do. So I just added this line of code and altered this one just a little bit. So this is how it was. I added that when it's less than 80 degrees outside, which is low ambient mode, and the liquid line drops below 88, because you want almost a 10-degree approach probably on a liquid line at all times in those conditions. And then and the pulse width modulation, my duty cycle is already greater than the minimum. This basically stops it if it's already at minimum. Then go ahead and decrease it, because you know the liquid line's getting too cool. But that's with those conditions. Or if we're above it, we're 80 degrees or above, and the liquid line is below 88, and my pulse width modulation is greater than now at this point, right, we're warmer out at minimum plus 60, then it'll decrease. So basically, when we're over 80 degrees or above, which we are now, it's going to ignore this one, where it can continue to slow it down to frequency minimum. When it's over 80, it's only allowed to slow it down as much as frequency minimum plus 60, which is just, I'm just putting a minimum duty cycle, so it's always going to run slow, basically, when it's over 80. It's never going to stop. So, and when the fan's already running, it could speed up pretty quickly. Versus when it wasn't, there's a little delay in these ECM motors getting it going, and then it's got to start from that minimum duty cycle, and it goes up several steps before it even gets to a value that makes the motor start. So I want to make sure that it always runs when it's warm enough to be running. It'll still kind of automatically run. I don't even need to put this in. I really could just put a fixed speed and let it run, or a little range, but I think it's cool just to have it automatically control the fan speed. So we're going to go ahead and write to that. Because basically before, I just had that ECM motor that was on my Linux just running 2 speeds. Build failed. I got to see why. I left something out here. Expression. What? So it doesn't like this. Dash dash dash. What did I leave in there? I left something in here weird. So let me find that and fix it. It could just be that I'm trying to do an OR between both of those expressions, and maybe you can't do that on a single if statement. So all I need to do probably here is break those into 2. So oops. In the bracket, finish that statement, and then add another one if that. So it's just going to make it into 2 of them, and I think now it'll take it. Doesn't look as cool. And I don't know what I need to do to fix that. Okay, I just hit the little clean button and it loaded completely, or compiled fine. So now, my programmer to go is grayed out still. I don't know what that deal is. So let me try just removing and adding the device back. Connected. Okay, I need to take it out. Maybe it's got to start the whole sequence again. No, it's still grayed out. I have no idea why. So clean. Huh. Oh wait. There it goes. It came back now. All right. Connect the programmer. That's an old message from last error. Seize the pit kit. Hope it's not too loud with this fan going. It's still building it. All right, it's done. So I'm gonna go write this into my unit now. Okay, just hit stop on the VFD. Fan's still running. It was maxed out at 200, which I might need to turn that up even more. I don't know. So every time it switches reversible, I'll be lucky it doesn't introduce noise. Reset this thing. So compressor just started. Fans are already starting at above minimum speed. Liquid line's 92, so it's still increasing. So fans are already running and speeding up. So didn't have to wait what was taking good like 10 seconds or so before, at least. It's not longer than that actually. So it should end the issue with it overshooting on the liquid line temperature. Do the fans take it too long? Now also that's a little warmer, I could start playing with my maximum fan speed. I can keep speeding them up. I can make these fans like haul ass, but there's a point of like diminishing return on that to where, a little better, control the liquid line temp, and then eventually you just keep adding fan speed and it's not going to really make the coil reject heat any better. And you're just increasing the amps on the motors. I know someone put an amp meter on these 2 motors running together, and you crank it up, it's actually like 3-4 amps, which is a lot. You gotta think there's a little quarter horse, in these things, or in the Linux I had, it was pulling, less than an amp. So right about that. What is it for 230 volt single phase? Something like that. 1 amp, you're your I guess your split capacitor runs are like 1.4 when they're running. This one's rated 1.8, I can see. So running like 3 to 4 amps is not efficient, but when it's running just enough for what it needs to be, these things are like very efficient. So it's up to 210 at 211. I did up the maximum, I forget what I set it to, in my hard coding that writes to the EEPROM when I flash it. So it's probably got plenty now. I can even mess with it a little more. Okay, fans up at 225 for my value, 8-bit value, and whatever the voltage is. Feels like it's blowing pretty good actually, so I'm gonna leave it right there. Oh, it just went from high to low, so the thermostat must have dropped a degree or so. And the ecobee is doing what the ecobee does. It's really quiet when it's on low speed, especially when I put this panel on. All you can hear is the check valves rattling. And the only reason you can really hear that is because I'm standing behind this. The phone's trying to get rid of the sound behind it and focus on what's in front of it. So with the magic of multiple microphones, so whenever I'm recording this unit, it makes the unit louder than it really is standing here, and then kind of diminishes my voice because I'm standing behind narrating. So there she goes. Oh, it's glory.